Hello, how we doing? This is the homework I'm going to show you all. Now, this is homework 1, and it comes from section 1, 1.1 that is. So let's look at it. Now, this wasn't the labeling scheme that we had in class, but I just want to sort of mind my P's and Q's, so to speak, and long story. But the first problem that you had was this problem right here. The second problem that you had was this problem right here, and so on and so forth. So here's the homework. The third problem you had was this one. And this is the letter X right here. If you can't read my handwriting, I tried to make it legible. Here's the letter X right here. But anyway, I tried to make this legible. And again, here's another letter X. Here's a letter X. So copy. This will be your homework. And I'll try to stay put. You can pause this at will. Just hit pause as you need to. So again, there's 1, 2, 3, and 4. Hit pause. There's 5. Now for 6, 7, 8, 9, and 10, and several others, you've got to solve for a variable. Like on number 6, you've got to solve for R. And 7, you solve for the letter little a, and so on. So write these down. Hit pause. You'll probably need to hit pause. Okay, let me go on down. Here's 11 and 12. Hit pause if you need to. Here's 13. Again, there's 11 and 12. Hit pause. Here's 13, 14, and 15. Along with 16, hit pause if you need to hit pause. Okay. There's 17. And, well, that's the end of that one. Okay, that's nice. Okay. Now, that's the end of homework 1. Now, homework 2, homework 1 will be due by the end of this week. No, that's homework 2. We're going to save it for later, and I'll just make my first test over homework 1. And that way it won't be so compactified. But after test 1, I'll start homework 2, and that way I can give a test fairly quickly. But here's homework 2. So in homework 2, you can solve this. You can use the quadratic formula, or when you can, factor in. You can't always factor, but you can factor when you can. It'll just save you the trouble of having to use the quadratic formula when you don't have to. But anyway, here's for the second homework. You can come back to this video later for this second homework. You don't have to do this video now. If you'd rather just focus on your first homework, you can come back to this later another time. But anyway, if you're ready for the second homework, here it is. I know the time is going to come when it is time for this, so let's just assume that now's the time for the second homework, and the time has passed. So here's the second homework. And let's say the first test has been taken, so we're deeper into the semester, then you would do this. So here it is. Here are the first 5. Hit pause if you need to hit pause. The pause key. This is the letter X here. Here's the letter X. Here's the letter X. This is X squared. Well, this is X squared, and this is X squared. This is the letter K, or K squared. But anyway, this is X squared. This is X. This is X squared, and this is minus X. I tried to make my handwriting bearable. But anyway, there's the first 5. Now there's number 6. And this is a plus sign. I kind of messed up the plus sign. This is 4x plus 1 parentheses squared minus 25 equals 0. But there's 6 and 7. And there's the letter X. And again, you're solving x minus 1 parentheses altogether squared equals 0 for number 7. Okay, and then 8, 9, 10, 11, 12, hit pause, and you'll complete the square on those. It's not going to be the same expression. You're going to change the expression. You're going to complete the square. So hit pause. Okay, and likewise, you're going to do the same thing for number 13 and 14. Hit pause. And this is x squared minus x here on the number 14. Now, you go back to solving, but on these you should use a shortcut. Don't do the quadratic formula on these. That would not be a smart thing to do. Hit pause and do these. Now again, you could do the quadratic formula, but I wouldn't advise it. Now on these, before we go to number 20, I need to give you a little background. This is called a factor tree, and there's more than one way to do these. There's a whole bunch of different ways you can do a factor tree. I just did it my own little way. 108 is 2 times 54, 54 is 9 times 6, 9 is 3 times 3, whereas 6 is 2 times 3. So you got 2 2s and 3 3s, 2 times 2 times 3 times 3 times 3, which is 2 squared times 3 cubed. So if you do the square root of 108, you're doing the square root of 2 2s and 3 3s. But in a square root, notice that's a square root of 2 2s, 2 3s, and 1 3. You take things out by the pairs, and the pairs come out as a single entity. So this pair of 2s comes out as a single 2. This pair of 3s comes out as a single 3. Now, this 3 that was on the inside, it can't come out because it doesn't have a thing to pair with. So it stays in. But now, notice that 2 times 3 here is 6. So that's 6 radical 3. Okay. And now the cube root, you take things out by the triples, or the triplets. So 2 squared times 3 cubed, you can only take out the 3 cubed, and it comes out as a single 3. It comes out as a single entity. The triples come out as a single entity, not the pairs. So it's 3 times the cube root of the 2 squared that stayed in, but that's 3 times the cube root of 4. 2 squared is obviously 4. Okay, and then that'll give you the background. Okay, and I do another example of 5,000. I do the 4th root of 5,000. I'll let you copy that down. I prime factor 5,000 into 2 cubed times 5 to the 4th. This is probably one of the better ways to do it. There's several factor trees you could do, but this is probably one of the nicer ways to do it. You get 2 cubed times 5 to the 4th. I kind of made a typo right here. But anyway, I prime factored 5,000. And I wanted to do the 4th root of 5,000, and I kept making typographical errors. But that's the 4th root of 2 cubed times 5 to the 4th. So, but that 5 to the, we take things out by the quartuplets. So that 5 to the 4th comes out as a single 5. And we're left with 5 times the 4th root of 2 cubed. So that's 5 times the 4th root of 2 cubed is 8. Okay. 2 times 2 times 2 is 8. Okay. Now, oops, too fast. My bad. Let me go back up. So now that I'm going to leave it for you to do these 3. So hit pause and write these 3 problems down right here. And that may do it for that section. Okay. Now, homework 3, 1.3. Now, guys, this is the letter I, as in I, literally, as in ice cream. I is the square root of -1 in mathematics. This is I for the square root of -1. And so is this. This is the letter I. I didn't put my dots very well on these first 2 I's here and here, but these should have better looking dots on them. But you just simplify these, like 6 plus 1 is 7, and understood 1 plus 2 is 3, 7 plus 3i. But you go through and you do a similar thing for all these, but you simplify these. So write down these first 5, okay? Hit pause and write these down. Okay, now write number 6. That's multiplying. Keep in mind you're multiplying here, here, and here. And yeah, you start multiplying on number 4. Okay. And hit pause and write down number 7, number 8, number 9, number 10. All those are multiplication / exponentiation. Okay. And now conjugates, I give you a shortcut. You could do this the old-fashioned FOIL way, but I'd recommend taking advantage of my shortcut, guys. A plus bi times a minus bi. You could do FOIL, but what you're going to find is you're going to get a squared plus b squared. This is a plus sign here. Now, for example, 5 plus 6i times 5 minus 6i. By this form up here, that's the a is 5, b is 6. So it's 5 squared plus 6 squared. And by order of operations, it's 25 plus 36, and that's 61. Take advantage of this when you do these. So copy these down real quick, and I gave you some helpful hints, by the way. This is number 15. I want you to do 6 plus 0i times 6 minus 0i for number 15. And that's very easy. That's very easy to do. So 6 plus 0i times 6 minus 0i. That's just 6 times 6, guys. So number 15 is easy. But copy these down. And number 16 is right there. I times negative I. It's positive 1, but I want you to see why it's positive 1. So, just number 16, just give it a thought. And here's 17 and 8. Now, I changed the gear just a little. On 17 and 18, I want you to rationalize denominators, starting at number 17. So write down 17, 18, 19, and 20. And these keep going for a little bit. Now, there's 21 and 22. And here's 23, 24, and 25. And then, now here I want you to use shortcut methods on some of these. Here, subtract 5 from both sides. Well, you can subtract 4 over and do, do differences. The sum is squared, you can factor this as z plus 2i, z minus 2i. If you want to subtract 1 over and factor z squared plus 4 is z minus 2i, z plus 2i. Or you could subtract 5 over, get z squared equals negative 4, and get z equals 2i, negative 2i. But either way, quadratic formula is not really helpful here. But it is helpful. You'll need the quadratic formula from 27 and 28. 29, you can factor this as 3z minus 5i times 3z plus 5i. That might be the best approach. You can also subtract the 25 over, then divide. This is 25 right here. But you can also subtract the 25 over, divide by 9. You get z squared equals negative 25 ninths. Take the square root. That's 5/3 I plus or minus. Excuse me. That's plus or minus 5/3 I. There's a positive and negative version always in these square roots. So it's positive or negative 5/3 I. But you need to go through the rigor and see it for yourself. And here's now number 30. You're going to need the quadratic formula. Blah blah. Now 31 through 34, I want you to simplify these. It's all about the multiple of 4. Like on just subtract 16 from the exponent. Now on 32, you'll add 8 to the exponent. 33, you'll subtract 8 from the exponent. On 34, just do it. Just do I times I times I. Do associativity. What do you get? And so on. Now on 35, I want you to rationalize. I want you to clean square root of 108 up and see what you get. This is going to be a real number. Maybe not a pretty one, but it'll be real. This will not be. And on 36, guys, I didn't say it, but I'd like it if you did it. I want you to break the real part off from the imaginary part, please, on 36. On 35, it's all real. But 36, it's not. Okay. 37 and 38, same. Now, 37 is going to be a very two pretty real numbers. Well, they might be fractions, but they'll still be nice real numbers, albeit they may be fractions. Yeah, one of them will be an integer, and one of them will be a fraction, but it'll still be fairly nice. One of them will be a very nice integer. But anyway, they'll both be real numbers, but here you'll get complex numbers. Okay. But I want you to simplify and reduce the fractions. I want you to reduce those fractions, okay? Reduce the fractions, guys, okay? Reduce, okay? So that's all for now. Thank you. Bye-bye.